homeostatic organs. Homeostatic organs. Now, we have some examples of homeostatic organ in the body. We have the skin, we have the kidneys, we have the liver, and we have hormones. These are examples of homeostatic organs. These organs, why do we call them homeostatic organs? You call them this because they help the body system, internal body system, to maintain a fairly steady environment. Because they help the body system to maintain a fairly steady internal environment. We say they are what? Homeostatic what? Organs. Now, these homeostatic organs, they are very important in the system because now let's talk about the temperature. For example, temperature. If the temperature of the system increases to a certain level, the enzymes, the cells of the body, they tend to die. Especially the enzymes will be denatured. They will not be effective. For example, most enzymes does not work very well when the temperature is up to this. Once the temperature is up to 40 degrees Celsius, most enzymes, they are already dead. They are already denatured. They will not be functioning anymore. So this is why these organs are very, very important. In some other area, we notice that the pH of the system can also affect the activities of the body. So in this case, these organs also help to regulate the pH, the hydrogen ion concentration in the body. There are also other things they help us to do. For example, removing of some waste products, ions like hydrochloric ions, chloride ions, and some other substances that the body might not be needing that may cause harm to the body, just like the fluid, excess fluid in the system. These homeostatic organs help us to regulate these things in order to maintain the osmotic pressure. So now, what is this homeostasis? That's what we're going to be talking about now. Homeostasis. When we talk about homeostasis, what really run in your mind? What really come out? What do you really think about when we talk about this? Now, when we talk about homeostasis, what we really mean is this is a process, the process of maintaining a fairly steady process is a process of maintaining I can say fairly steady internal environmental, let me use that, environmental conditions. I said that homeostasis is a process of maintaining a fairly steady internal environmental condition. Now, why I said fairly, because most time it's something that changes continuously. It's not really, you cannot come at the point all of them. It's either they are trying to drop it, they are constantly changing environment due to what is going on in the body system. So that's why I said it's what's fairly, because the body is trying to make it steady, to maintain a steady environment internal environment that can sustain the activities in the body system. Now, organisms can carry out this process by doing what? What do they do to maintain this process? One of the things they do to maintain this process, they do this by also regulating any changes. They do this by regulating what? Any changes that will likely occur, that will occur in the body, in their body fluid. Any changes that can occur in their in the condition of their body fluid. Now, whenever the condition of the body fluid changes, it will affect the what? Homeostatic state of this body. It will not make them to be at balance anymore. So, some of these things they checkmate is what? The pH, which is hydrogen ion concentration. Note that that is one of the things we the homeostasis process checkmates the hydrogen ion concentration. Another one is the temperature. I've already told you this, and also we look at the what? The osmotic pressure. But in this class, in this video, we are going to be looking at mainly how the skin play this very important role. We are going to pay serious attention in how the skin help in this process. So the skin is known to be the largest organ of the body, especially in the vertebra, because it covers every part of the vertebral animal. The vertebra is known to cover every part of it. So for that reason, it's considered to be the largest organ. Now, this skin, we have the animals they have. In some animals they have a lot of a dense growth of what? Hairs. The growth of hairs. While in some other ones they have what? Small. mm, they have the hairs in small part of their body system, just like in human beings. In human beings, they are just a kind of sparsely dispersed. So what we have here is the structure of the skin. So this is just a sketch of what the skin looks like. Now, if you look at it closely, you find out that the skin is made up of mainly two layers. It's made up of two layers. The first one is the epidermis, which is the outer layer, and we have the dermis, which is the inner layer. So this epidermis is also divided into three layers. The first one we have here, which is the innermost layer, we call the Malpighian layer, and then the middle one is what we call the granular layer, and the outermost one, the outer one is the one we call the Cornified layer. Now this Malpighian layer is living. It has an active dividing cells. This active dividing cell contains what we call melanin. Contain melanin. This melanin is a pigment that determine the color of the skin, whether the skin will be fair, black, dark, as the case may be. This is what the main function of this melanin. So in this also, this Malpighian layer has a lot of infoldings. These infoldings penetrate deep into the dermis. These infoldings do what? They penetrate deep into the dermis. As they penetrate deep into the dermis, they form what we call the sebaceous glands. Sebaceous glands. This is the kind of gland that contain oil, fatty substances, oil-like substances in it. And again, some of them move into form what we call the hair follicle. The hair follicle, where the hair emerges. That's where the hair grows out. Now, this cell, this Malpighian layer altogether, another thing you should note about it is that since it's living, it can also it needs some nutrients and oxygen to survive. So this oxygen and nutrients the Malpighian layer require for its activities is is supplied by the blood capillaries we have around the dermis. The oxygen and the nutrient is supplied by the what? Blood capillaries we find there. The next one we look at here, we have the granular layer. This granular layer also is living, is made up of active and living cells. Living cells. And these cells, one thing about them is that they grow away from the what? Dermis. That means they move upward. They grow upward. As a result of growing upward, all the cells around here tends to be moving upward away from the Malpighian layer. They are also living. And as they grow up like that, going toward the surface, they form keratin. 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 This keratin, they are more of dead cells. They are made up of fibrous protein. They are more of dead cells. As they grow, as they form this keratin, these cells of this as these cells of the granular layer form this keratin, they will eventually what? They die. As they die, they help to form the what? The cornified layer. This cornified layer, they are made up of scale-like dead cells. Mainly everything we have there, made of the cells we have there. This layer is made up of more of dead cells filled with what? Keratin. And these cells here is always rub off as we scratch it constantly. Is going out, and as it's going out, it's being replaced by the granular layers, making that place not to be just porous like that. So but then one unique thing that you should note about this keratin is that is what is flattened and what rough, is rough and also tough. I mean, it's tough and flexible, making this area to be what? Waterproof. To help to what? To waterproof the surface of the skin. So the next thing we're going to into now, we're going to be talking about the dermis. Dermis is the inner part of the what? The skin, which is the like I told you earlier on, that the skin is divided into what? Two layers. The epidermis. Remember, epidermis and dermis. Now we're looking at the dermis. Dermis is a layer of um, connective tissues. Connective tissues, like you can see the sweat glands. Sweat gland is there. We have the sebaceous gland. We have the hair follicle. You can also see erector and other and something like blood capillaries. We also see can also see the nerves, nerve ending, and all the sensory nerves. For example, we have the thermoreceptor, the one I just there are so many of them here, but I just listed out this one for so that I will have to save space. The other receptor cell nerves there. We also have the sweat gland. The sweat gland has um, a, a passage we call the sweat duct. This sweat duct is a passage that allows the sweat to move from the sweat gland to the sweat pore where it is released. In this sweat pore is where it's released to the environment. So we also have the hair follicle. The hair follicle has underneath it, it has a capillaries and nerve ending. Because of that, actually the hair is made up of keratin too. So it can only respond as a result of what we have, the nerve ending we have underneath. So that whenever you touch this hair, it gives signal to the nerve ending here to make the body to respond to the touch. So the next thing we're going to be looking at now, as we have already gone through this, so we are going to be looking at this homeostatic function of the skin. The homeostatic function of the skin. The skin plays a very important role in what? Temperature regulation. And this role is assisted. The brain also help to assist the skin in doing this work. In the area in the brain where we call hypothalamus, the hypothalamus, there's an area in the brain that we call hypothalamus. The hypothalamus is the area that plays a very important role in this work. Now, in hypothalamus can detect the temperature of the body in two ways. I want you to know that way. Number one, by what? Monitoring the temperature of the blood. That's one of the ways the hypothalamus will help to dictate the temperature of the internal system. Number two, hypothalamus can also dictate the temperature of the surrounding, that is, external surrounding of the where the organism is living. The external surrounding by the help of the what? The thermoreceptors. These thermoreceptors is the nerves that are sensitive towards temperature, thermoreceptor. So what they do that they get the signal and send it to the hypothalamus, which gives response, which send a message to the world, the skin, to take action. Now, within this hypothalamus altogether, hypothalamus has a thermoregulatory region or center, and this center is divided into two parts. This thermoregulatory center is divided into two parts. One of them, I think I can clean some area here. One of them is the one we call heat loss center. The second one is heat gain center. These are the two centers we have in the hypothalamus. Now, what happens here is that when the external temperature is very hot, the heat loss center will be stimulated. Now, we call it heat loss. The function of this heat loss is the area that helps the body to lose more heat, while the heat gain center helps the body to what? Gain more heat. So when the temperature of the surrounding is too hot or high, what happens here is that this heat loss center will be stimulated in order to encourage the loss of heat from the body. Now, this thing is achieved by what? Number one, vasodilation. The second one is what? Sweating. By sweating. The next one is decrease, because the temperature is high. So there will be decrease in what? Metabolic activities. The next one is lowering. I can say lowering of the hairs. Lowering of the hairs. Now let me quickly explain this. So when we come to the vasodilation, what happens here is that the blood, remember in the skin we have capillaries and arteries that pass through some of them. The capillaries that pass through the skin, what happens is that once the temperature of the surrounding is too high, blood will carry more, the capillaries will carry more blood to the surface. As it gets into the surface, the heat in the body system will be, the body will lose heat by what we call by conduction. One. Another one is by what? Convection, and also by radiation. Heat will be, the body will lose heat by this process. By losing this heat, the internal body system will maintain a relatively constant environment, internal condition. Now, another thing that happens here is that as this thing is going on, to increase the loss of heat, remember this place is playing a very important role in heat loss. What happened here? The sweating process will increase. There will be increase in sweating. As the sweating is going on, the sweat will pass through the sweat dots down to the sweat pore. As it gets to this place, it will vaporize. causing a kind of cooling effect. Remember that vaporization causes what? Cooling effect. There will be cooling effect that will take place here, resulting to what? Drop in this temperature. Note that very well. These are some of the ways the skin plays the important role of what? Homeostasis. Is that okay? Now, the next one is we'll get to the decrease in metabolic activities. Now, when this is happening, remember the liver is also a very important organ for homeostasis. Now, what happened here? The activities of the liver, metabolic activities of the liver will drop to some extent in order to reduce increased generation of heat. By so doing, the body's internal organs will remain, the body, the temperature will not be that high to maintain, to sustain the life of the cells there. So the last one we have the lowering of the hair. When this what happened here, we have the erector muscle here. This is the erector muscle. I want to pay attention to this, even though my drawing might not be that wonderful, just a sketch to help us get things done. So we have the erector muscle here. This erector muscle, when this temperature is high, is environmental temperature is high. What happened here? This erector muscle will relax. As it relaxes, it draws this root hair, that is the hair, down, making this place to be open. As it opens, heat can also go out of this place through what? Convection. More heat will be passing out of it. So now the case is different when the temperature is low. When the temperature decreases, this is when the heat gain center will be stimulated. The reverse will be the case in this one. When this one happens, when this thing happens, when the temperature is low, surrounding the environmental, external environmental condition is low, what we notice here is that the hypothalamus will stimulate the part, that is the heat gain center. What then will happen is vasoconstriction will occur. We also have low sweating. Let me use that word, low sweating, or sweating will stop entirely. Low sweating or stop entirely. The sweating can stop entirely because of this process. So the next one we have was increase in what? Metabolic activities. Increase in metabolic activities, their metabolic activity will be very, very high this time around. So the last one I want to talk about here is we say that the hair raising of the hairs. Raising of the hairs will go up. Now let's quickly explain what happened. What do we mean by vasoconstriction? In vasoconstriction, the superficial capillaries in the skin will constrict, forcing the blood to go beneath, no more to the surface. Once it constricts, the blood will stop coming to the surface. Remember what happened in the height loss state. Then once blood stop coming to the surface of the skin, then more heat will be conserved because all of them will be moving underneath. Understand? So that will help us to help the skin to conserve the heat internally. Now, the next thing is that there will be low heat or no heat at all. Low sweating or no sweat at all. In the sense that because of this, because this sweat will result to what we call loss of heat. So for that reason, sweating will stop entirely in order to conserve the heat internally. So the next one is increase in metabolic activities. As the liver and other organs speed up, increase their activities, what happens is that it generates more heat to maintain the internal system. So the last one we have there is raising of the hairs. Now what happened here in this case again is that this erector muscle, pay attention, this erector muscle will what? Contracts. When it contracts, the hair will not go up, blocking this place with the help of the sebaceous gland that will, it help also in insulating this region so that there will be no loss of what? heat via these openings we have here. So by so doing now, what happens is that the body has succeeded in maintaining the body, the temperature or the internal environmental, that is internal environmental temperature. So the temperature at the end of everything in each of the case, be it that the temperature of the surrounding is high or the temperature of the surrounding is low, the body will still maintain 36 to 37.7 degrees Celsius. So it will fall within this range. Remember at the beginning I said it's fairly constant internal environment. So if it's always fall within here, it cannot be steady in most cases. It's either it's there or there. So as there's a kind of increase, the body will change its process to drop it again. When the temperature is going low, the body will change the process to bring it up again. So it's always falling within this range. So this is where I'm going to stop this class today. If you have any question, you leave it in the comment section. I thank you so much for being part of this class and for being here. It means that you are amazing. You are amazing and you are very, very serious to learn. In fact, another thing I want to let you know, remember to subscribe if you're joining us for the first time, and